Good afternoon, everyone. I am Harmeet Singh. Today is my topic on simplified Scala monads and transformation. Here is my Twitter handle, and just a quick and brief introduction about me. I am Harmeet Singh, module lead software consultant at Singh, with 5+ years on a JVM and 2+ years with Scala. And about Singh, Nolde is the only platinum partner of a Lightband throughout Asia. We are working on complete Lightband stack, Databricks, DataStax, Confluent, and other cutting-edge technologies like Rust. Here, our partners are Lightband, DataStax, Confluent, and Databricks. So, let's move into today's roadmap. So, today's roadmap is a brief of functional programming. Just a brief introduction about functional programming. What are functions? What is actual function compositions? Monads, handle side effects using monads, and monads transformations. So first of all, a brief of functional programming. This is the most famous tweet, one of the Scala champ, John DeGois, and he described the functional programming within his tweet. FP is just a programming with functions, and the functions are total. They return an output of every input, deterministic. They return the same output for the same input, and pure. Their only effects is computing the output, and the rest is just a composition you can learn over the time. This is a brief of the whole picture of functional programming. Now, what are functions? If you see in this diagram, we have a box, and box performs some business logic, and that business logic is he chopped the apples. The apples are an input, and output is a chopped apple. So that box is performed an action as a function. And as we know, like most of the computer science concepts are derived from the mathematics. So as you know, the functional programming is also derived from the mathematics. That means we can also define function in mathematics. So how? Let's see how we can define functions. F of x equals to x plus 1. F of x y equals to x plus y, and f a b c x equal to. This is the simplest way for defining a function within a mathematics. But these functions have some properties, and those properties are, functions are pure. What does it mean? Output of the function depends only in its input. If you see in this output of every function, it depends only its input. Functions have no side effects. We will see later what are side effects. And all values are immutable, and they are more. There are lots of definition, lots of things throughout the internet. You can search it, but these are the most simplest way for defining a function and their properties. Okay, now how we convert these function or write this function in a Scala. Def of x equals to x plus 1, def x y x plus y, and f a b c x, and this whole expression. This syntax is similar to the mathematical functions. So that means these functions, the Scala function has the same property, like immutable. There are no side effects, and they are pure. Now, what is function composition? Given two functions, we can combine them in such a way so that output of the one function becomes the input of the another. The simplest form of composition. We are all familiar with the command line interfaces, like Linux commands are there, and we can use the grep command. The output of one command is an input of another. So same things actually implemented in a functional programming. The output of one function is an input of another, which is called function composition. And let's see by using this via this diagram. So we have two functions, g and f. 3 is an input of g, and the output of g is a 29, but 29 is an input of f, and the output is 86. So if we compose this function, this described as like this, f of g of 3. This is called function composition. Okay. Now enough talk. Let's see some code. Okay, yeah, here we are. Where is terminal? Okay, I'll trying to check out from here. Yeah, So this is the most basic Scala code, the core Scala code. We are defining two functions, function f and function g, which accepts an int and return an int. Both are performing the same thing, and like this is the simplest way for composing a function in a Scala. Okay, and there is another way for composing. These are the methods, and as we know, Scala contains a type, function types as well. So how can we compose those types? Okay, just a minute. Yeah. Okay. How can I check out this? Again, I guess there's a problem with the terminal. Okay, yeah, we have terminal here as well. Git checkout example 2. If you see here, so like in the previous example, we are using the methods, but this time we are using types, function types. Both are different. Methods are associated with the objects, but types are these function types are associated with the type. So we are defining a type here int to int. Say the same things. It accepts an int, g accepts an int, return an int, and we are performing some business logic. And for composing those functions with function types in the Scala, we are using this and then method. And if you are familiar with the other Scala pure functional libraries like Scala Z and Scala Cats, via those libraries you can use map and other things for composing these types of functions. Now, function composition, everything is okay. For composition is a good, but what happen if we are having these types of function? Okay, yeah. In the last two examples, we have a function which accepts a single input and return a single output. But what will happen if we have these types of function? Accepts an input by returning a tuple. So for resolving that kind of issue, we are calling this G with an input and extract its output and then pass a required input to the next F, then performing our results. But the problem with this example is this is not exactly the function composition. So how can we resolve that problem? Okay. Now moving to the next example. So before moving to the next example, in a Scala we have this for expression. There is no for loops in Scala. There is a for expression. Everything is an expression, and this expression is actually converted into this flat map and map call. This is just a syntactic sugar, nothing else. Okay. So this, if we execute this example, we are getting the same results. Okay. Now let's move and resolve that problem. Yeah. So this is our problem. Function returns a tuple rather than a single value. So how we resolve that problem? So for that we are creating a case class. We are creating a class which is called writer. Its constructor accepts two arguments, an int and a string, and we are defining two methods within this case class, map and flat map. These are higher order function accepts lambda, like map accepts int to int and flat map accepts int to writer. So these are just standard functions and returning the writers. Map returning a writer, and so the map and flat map in which class we are defining map and flat map, they actually must return the same type. Like this, they must return the writer here, and the flat map also return the writer here, and it within this lambda expression it accepts an int and return this writer type. So now what we are doing here, we are actually refactor our methods f and g, rather than returning a tuple, this time we are returning a writer. Okay? We are returning this f returning a writer, g returning a writer, and we know in the Scala there is a for expression, there is a syntactic sugar. If we are using this expression, this actually automatically converts this method g and f calls into this flat map and map. So this is the another way for composing your function via this four expressions. And the whole step which we are doing here, the way we resolve our problem, this stuff is actually called monads. Here we are creating this writer, actually here we are creating our custom monads which help us for composing our methods. This is the most simplest, or like the beginners for learning monads for beginners, most simplest way. And we can describe this monad like as this. So this is just for the beginner's perspective. If a class contains method signature like a map, flat map, and pure, in that case, just suppose that class is called monad. There are lots of definitions, there are lots of things in a monad, there are mathematical equations for a monad, but for the beginners and for the simplified purpose, if we are explaining the monads, is just if a class contains map, flat map, and pure methods, that class is called monad. And when we will use those monads, if we process some values and require to pass intermediate result to the next, as we know in the function composition, we say one output of one method is an input another. But if we require to pass not fully exact output but half processed output, in that case monads come into the picture. And the next thing is, if we need to perform some side effects within our application, without side effect there is no possibility to build an application. Okay, so in that case monads come into the picture. So these are just more basic things which monads help us to resolve or resolve that part. And now moving to the next, this is just a simplest form of the ensemble of a monads, which contains these three methods: pure, flat map, and map. Same standard signature, nothing new is here. So, but in the last example where we created our writer, monad, in that class there is no pure method. So how we call that class as a monad? So this pure method, if you see this declaration of this pure method is actually accepts a type A and wrapped it into the something of A. Okay, so in a Scala, in the last example, we are using case classes. In a Scala, the case class provides a method apply which performs the same thing. It accepts a normal input and wrapped it into the defined type. Okay, so the name of the pure method, it depends on the various implementation of monads. Like in a core Scala language, there are some monads, but no one contains like a pure method, but they are using this pure via apply. But if you will go with the Scala Z and Scala cats, you can find out various method like a pure, lift f, or another one. Okay. Now, what are side effects? If method returns a unit, if method change the application states, if method talk with any third-party resource like database networks. So, as I told you, monads is used when the side effects, when we require to perform side effects. So what monads actually performing on that side effects? So while we are searching on the internet, lots of the developers said these monads actually create your side effected method into a referential transparent. It makes your side effected method into a referential transparent. How is it possible? Okay, let's move with an example. Okay, yeah, here we are. Yeah. So yeah. Here we have three methods: find user, perform some database operation, like this is performing some database operation, and get address and send an email. So these two methods are interacting with the database, and the third one is interacting with any sender or send email APIs. And so for resolving that issue, as we know, if side effects come into the picture, we need a monads. So here we are creating a class which is called IO. It accepts a type parameter generic, and in this constructor, the constructor is private, but it accepts a pass by name parameter. In the Scala, this parameter, this type means this the expression which we are passing, the value which we are passing within this IO is actually lazily evaluated. Okay, and we are creating two methods here, flat map and map, like with the standard signature and define its implementation. And in the companion object, we are defining an apply, which help us to wrap this normal value into the IO. Okay, now, so here, via using, as we know, the for expression is also used for composition. So here we are composing these or three methods via IO and performing our action. But how this IO makes or converts this find user and get address into like a pure into pure method, or makes it as a referential transparent. Okay, let's see. If I comment this, and if I run this code, yeah, here's an output. I am adding some logs here, the println and send an email, but no log is print actually into the console. So what actually happens? As we know, these monads actually create an illusion for us. There is no way to make your side effected method into pure, but it creates an illusion. It executes this method when it requires, otherwise not. Doesn't matter how many times I execute this for expression, 50 times, 100 times, and million times, it always returns the same value. This IO find user is actually means, this IO find user actually means it doesn't execute this find user method. It actually defines how to find a user, or it retrieves how to find user via ID. And same as with the get address, same as with the send email, these are not actually executed our methods. These are just returning a definition of those methods. And when it executes, if we require, then we execute it now. Yeah, here we are. Now it actually executes our method. So there is no way for makes your side effected method into pure, but it's an illusion, nothing else. So monads create an illusion for us. It's lazily evaluated. So this is the main reason some of the Scala developers are not agree like future in a Scala is a monad, because future is not a lazily evaluated. And there are lots of problems with future as well, but one of the problem is future is not a lazily evaluated. It contains map, flat map, and apply, but still the problem is same. Now these are the now somehow we get an idea about what actually monads is, the basic idea. Now moving to our next example. Okay, yeah. So this example is actually now we are moving to some example. This example is actually written by Gabriel Petronella. Why I select this example? Because these examples actually are more much more close with the real life problems. Like So that's why this example help us to learn about monads transformation. Now we have in this example we have a two method, find user and get address. Find user returns and future of user, get address pass and user returns the future of address, and we are returning the value. And via using for expression we are composing our function, because we know this for expression is actually converted into a flat map and mat calls and just a syntactic sugar, and we know this future contains flat map and map methods. And if we execute this example, okay, if we execute this example, okay, yes, yeah, everything is running fine. But what will happen if what will happen if the user is not exist? This user ID user is not exist. Maybe we are getting our null pointer exception, maybe we are getting future failure. There are some problems definitely. So how can we resolve those problems? Okay, Scala provided a beautiful feature which is called an option, and here we have, rather than returning a future of user, we are returning future of option of user, future of option of address. And we know like we need to compose the function like this, but we have a problem. This is not a way for composing a function. This time we only have a two methods, but suppose next time we have a 5, 6, 7 methods call. So every time we need to perform pattern matching, because find user is actually returning a future of option of something. There are two wrappers there. It remove the first wrapper, but the second wrapper is user of option. So for removing that wrapper, we need to use pattern matching here. So we have another we have another problem with this as well. Yeah. So this time this find user returning list of option of user, and get address returning a list of option of address. But the problem is still same. We need to, this find user returns use option of user, and we need to extract that via pattern matching. So how can we resolve that type of problems? In that case, monads transformer comes into the picture. Just a quick definition of monad transformation. Monad transformer is to help on working with an inner monad that is being transformed by an outer monad, like f option of A can be turned into option of T, fa, where f is an any monad. It's a typical definition. Maybe I'll explain you via example. Okay. Yes. Yeah. So these are what methods, list, find users and get address list. This returns list and option of user, this return list of option of address, and we are performing pattern matching here. Same with the future, we have two another methods, future of option of user, returns future of option of address, the same solution using a pattern matching. But the common thing within these two problems is the pattern. We always need to perform the same thing, like we need to perform this pattern matching, then pull out this value to the passing to the next. So is it possible for creating a generic class which perform this operation, which perform this operation, and we can use that class again and again? Yes, it is possible. So here we are creating a monad trait which is called monad, which accepts a higher candidate type, and it contains the three methods, pure, map and flat map, the standard definition of these three methods. And we are defining another case class which is called an option T, which accepts a value which is m of option of A. because in these two problems we have the same pattern. The option is always same, maybe, but the outer wrapper and the inner value could be changed. So in this case, this option T accepts a value which is a generic type. The outer may be different, inner may be different, but the option is always same. And we are defining our type parameters here. And in this flat map, it accepts a higher order function. It accepts a lambda expression, and it also accepts an implicit type of monad M. And what we are performing here, we are just delegating the implementation which is passed by this monad M, and we are performing the same pattern matching here. The pattern matching which we did in our earlier problems, like here. Like here, we are performing the pattern matching. We are performing same thing within this flat map as well. Okay, and this is the definition of map. Nothing new. We are just delegating the implementation of map to the past monad map, a monad type object. And if we required, like so, I want to use this monad type with the future. I want to define this monad type of list. So that's why I'm overriding this new monad type class and defining the implementation of a future and a list. There is nothing new. Like as I know, the future is actually converting this normal A type into a wrapped into the future. So in the Scala, future contains a method which is called successfully, which performs the same thing. And we are overriding this map and the flat map, and we are delegating these calls to the future map and future flat map, same with the list. Now, if we are using this class, this time I am using this option T class. I know this find users returns a list of option of user, and I wrap this call within an option T. Now via this generic via this generic option T, this actually returns a user, not an which actually return a user, not an option of user. So if you see here, get address list. This get address list is actually accepting a user. So via this option T, we are extracting the value of user from the two wrappers and pass it to the next function. And after this whole computation, this actually return option T, which is a list of address, and via this value variable, we are extracting the list of option of user, and this whole stuff and this whole thing is actually called monad transformers. Okay, so Scala pure function libraries, as I talked about, like Scala Z and Scala Cat, they are containing a lot of monad transformer classes. Like option T is one of them, and so there is no need to reinvent the wheel again and again. So those classes are really powerful and optimized rather than creating your custom classes. I have one example of this Scala monad, Scala Cats option T. So here, so this is our function. Here we have three functions. Find user, which returns a list of option of user. Get address list, which return a list of address. Get company, which return option of company. The first one is an OK, but in the second one, the option part is missing, and in the third one, the list part is missing. So how is it possible to compose these three functions together? So Scala Cats provide a type which is called an option T, and for using that type, we need to import some instances, like the instance which we defined in our last example, like instance of future, instance of list, and instance of as per your requirement. So this option T accepts like the same as the M of option of something. So as we know, find users returning a list of option of something, which is okay. But get address list is actually returning a list of address. The outer wrapper is actually missed. So it provides a method lift f, which magically convert this get address return type into a list of option of addresses and return the addresses to us. And like in the third case, the list part is missing. So we have a from option, which actually convert this get company return type magically into a list of option of company, and returning via the composition, it returns a company, and we are using this with an ease, and we are composing these three functions easily. So if we execute it, yeah, everything is running fine. So this whole stuff is actually called monad transformation. And on the JVM, the monad transformation is the easiest way for resolving the problem, but they are not optimized on a JVM, because when we are using monad transformers, it creates lots of objects into the heap. Every time we are calling internally, it calls the flat map. So every time new stack is actually pushed within a memory. So there is a possibility you can get a memory overflow exception, you can get stack overflow exception. So monad transformers is not a good solution on a JVM. So there is alternative solution which is called free monads, tagless final, elf monads, and you can also use MTL libraries also. So these are all stuff. These are monad transformations, and you can download these examples and slide from this GitHub repo. And these are my references. Thank you. So we have 3 minutes. Do you have any question?
Yeah. Any questions? No one? Okay. Let's ask my question then. If you don't have any monad transformations, do you think is there any point on using in IO monad?
IO monads is actually performing or help us to perform some IO operation. So monad transformer is a different thing. IO monads is actually a different thing. I'm not sure these are actually.
Yeah, I understand your point, but the question is whether you really need to use IO monad in Scala if you don't use any monad transformers. Because in fact, what benefits does the IO monad give you? Probably it's the postponing of the calculations with side effects, that's it.
Yeah, it is actually. So IO is actually IO help us for performing some input-output operations. Like in the examples where we have a future of something like that. So maybe if we are using an IO, in that case you have something like IO option of something. In that case, monads you can use the monads transformers, but still monads transformers is not a good option on a JVM. For the JVM, you could use free monads and tagless final.
I'm not sure if free monads is a good option because it's kind of interpreter which is even a bit more slower than this, but anyway. But
free monads is actually implement a trampoline. It performs an action with a trampoline, so there is no need. So free monads is not actually push a stack every time. So there is a limitation of free monads. Like there is a huge boilerplate code we need to write while using free monads. But while we are using free monads, it doesn't matter which monads we are using. Every time that monad is performing as a stack save. But which is different from a tagless final. In the tagless final, the stack safety depends only on your used monad. Like if your monads are performing stack safety, then tagless final perform the action according to that. But if your monads is not a stack safe, then there is a problem with the tagless final as well. There are some solution with tagless final for performing a stack safety. But yeah.
Does anyone want to ask more questions?
Thank you for your talk. Do you think bifunctor EOR is worse or better than using EZT transformer? Which one do you think is better?
Sorry,
I mean, you can use EZT to represent error side of your I/O computation, and you can kind of fuse them in bifunctor EO type. And do you think it is a good way to represent that, or transformer is enough?
Actually, honestly, I didn't experimented with the bifunctors. But no, actually, about bifunctor and defining this. Sorry, I didn't get. I didn't have an idea about the bifunctors.
Okay, thank you.
Anyone else? Okay, you're welcome.
Thank you for your talk. My question is about generating MTL's monads. As I understand, if we have a lot of different transformation and a lot of different monads, we should generate for each monad their transform monad. So it became to some hell because we should generate a lot monads for this. Do we have some library to maybe macros generating this to automate this process? And should we maybe avoid this process?
Regarding monad transformation, actually, as I told you, there are libraries which is called MTL, Monad Transformer Library, which is completely different. I'm not sure why they named as an MTL, but which is completely different. They working on the complete types, which is actually which is depends on the algebra. You for performing this for creating this wrapper of something, you need to define the algebra, and MTL help us to via types. MTL help us to resolve that kind of issues. So there is for the monad transformer replacement is like as free monads is actually one of the replacement. The pattern tagless final is one of the replacement. There is a library, I am not sure, F monads actually are there, which is also provide a way for resolving that monad transformers problems. You can use that libraries as well. So yeah, there are a couple of options.
Okay, thanks.
Anyone? Okay, thank you.